Welcome to this episode of Robots in Depth. Today I'm honored to have Søren Peter Johansen, Technical Manager of DTI in Odense in Denmark here. And as usual, we're going to start talking about how you got into robotics. When did you start to discover you can build robots that go out there and do stuff?
Well, I'm actually 50 years old, so 50 years ago or 40 years ago, there were not that many robots.
No, I would presume so.
But I was technically interested. I know we had an old TV set which didn't work. Then we had another one, and I started actually to looking into these TV sets. And then suddenly I had one TV set working. So two TV sets not working became one TV set actually working. So I became very interested in these electronic devices. And as time goes, when I come to high school, I meet my first PC or first computer. So instead of having French lessons, I, sneaked into the computer room, sat there, and made my first computer programs.
I can tell you that I did exactly the same thing, and we were even so connivious that we actually broke into the room, and eventually the teachers realized that we weren't abusing it, we were just using it, and they realized it would be very hard to stop us. We were really good at getting into that room and staying there for as long as possible, so they simply gave us the key, and nothing happened, nothing bad happened for 4 years, so that's a very good place to start. Then you went from electronics to robotics. When did that happen?
Well, I actually went to the university where I studied computer science and physics, because still it was a long time ago and there were no robot technology educations in this area. So I might say that was as close as you could get on robotics. I started a PhD study, but suddenly I had no more money. So I had to look for money, and actually one in my family started up a blacksmith company doing some simple machinery, and I got to work at him for 14 days. And in these 14 days, I just had this dust of gold coming over all his machines. When he added a PLC, hey Søren, could you add some program to this machine so it could do something smarter, faster, more useful? And it became small miracles, and customers say, wow, this is a fantastic company. Can you deliver some machines to us here and there? And then suddenly, I actually skipped my PhD and started working with robotics.
In the best way possible, where there's a customer demand. There was a customer demand and you could meet it. Yeah. Could you talk about some of those early projects? Because I guess that's the beginning of the robotics era.
Yeah, my early projects was in the electronic industries, because it was kind of automated at the beginning with pick and place machines, but they needed a lot of handling equipment to actually get prints in and out, and to mill out smaller prints from the big print boards, etc., etc. So suddenly I was in a situation where a customer asked me, could you, on basis of our CAD drawings, actually mill out the smaller boards for mobile telephones? And I said, yes. I hadn't got a clue about how that should work, but then suddenly we had this task. And they actually paid us money up front. So then it was started.
Fake it until you make it, huh?
Exactly.
It can be a risky strategy, but I'm thinking we've all done it sometimes, right? And if you really focus and really delve into this, I did this when I started this interview series. You really have to delve into it and really focus on it, and then it isn't so much faking it until you make it. It's kind of willing it into existence. And you did that there. And then did you continue to work in your own business then, or?
Yes. Then I actually work at developing more and more advanced automatic machines, automation, and then. Robots became available, and then it was off with actually to take in robots in these solutions as well. Meanwhile, I left this company, started my own started another up with some more of these people that I met in this industry, and we became a company of 15 employees or so. And then we delivered a lot of automatic machines and included robots in these machines. And I found it very exciting what you actually could do with robots if you could add on some fancy software. And then 6 years ago, I went into DTI, Danish Technological Institute, because I could see here was really a chance to get to play with all brands of robots and in all levels, from commercial projects to Horizon 2020 projects, where we could really play a lot with robots and future possibilities that you can use robots for.
Both practical application and theoretical fundamental research and all in a nice mix.
And then find what was best in these theoretical projects, mature them into something that you could actually sell for money to the industry. That's very exciting.
So you've been with the Institute now for 6 years.
Yeah.
Could you tell me a bit about the projects you've been working on during those 6 years, starting with the earliest ones? Just take the best ones out of these 6 years.
I remember one of the first projects I had here. I came here first day, I asked for a really difficult projects. I want one of your difficult projects. I shouldn't have said that because I actually got one.
And that was very difficult.
It was very difficult. It was about cleaning some solar panels. And well, that seems easy if you just have a solar panel standing in a fixed place. But these panels were all over on mountains, on fields, and woo. But we actually had some success. We actually managed to clean solar panels.
Because of course, if they're not clean, they're not generating power.
No, but we actually figured out that if they're completely clean, they work worse than if they have some dirt on the surface. That was very surprising, and one of the.
So and that makes cleaning them hard, I guess, because you have to clean them to the right degree, right? You can't just wash them off.
You're right.
Which is odd. Do you know why that was?
They had some theories about this quartz material could take the sun from different angles and actually send them down to the solar panel, but they were not that sure.
That's odd.
But you know, it was a quite interesting project, because about robotics, when we're talking about robotics, robotics is about to actually try something, to do something and see if it works, and then optimize it. And this project was actually about that. So we did something, we got some results, and from there you can then fine-tune and optimize.
This is the difference between, for instance, pure software or simulation, that when you go out there in the real world, which good robots do, you'll discover the fact that a completely clean solar cell is worse than a slightly dirty one. And that's the stuff you could never think your way to. You have to go out there and do it and just get the experience.
Another big difference between pure software and robotics is that in robotics you actually interact with the environment. You have your sensors have to recognize what is here, what light do you have, what forces do you have, and the robot interacts by pushing some mechanics. So you learn a lot about processes. If you are adding a screw into a screw hole, something like that, with a screwdriver, you get some surprising results using a robot, because it feels the small details on a screw which operators are not even aware of. So that's very exciting, and the combination of people who are good at software and are good at actually sensing their environment are a brilliant combination, and we are all good at sensing our environment.
Yeah, because we are that as human beings.
Because we're born into it.
Yeah,
yes, exactly.
Yeah.
So the idea of developing robot systems that can actually be instructed, and I use the word instructed instead of programmed, but can be instructed by operators themselves, would really be beneficial for many companies their processes, etc., and the operators themselves, because they could get some more exciting work to do.
And working together with a robot is really no different than working together with your dishwasher or your washing machine. It's just more capable and more intuitive to work with. So we already are cooperating with machines, mowing the lawn, driving pushing a snowblower or anything.
Driving a car,
which
is a very complicated, dangerous device, actually.
And we have then, of course, ABS and stability systems of different kinds that are helping us. So this cooperating with robotics is not as odd as it might sound to somebody that isn't familiar with the area, but it is going to be very powerful when the robot can do what the robot is good at.
Exactly.
And the person can do what the person is good at. Do you see any progress in this area? Do you see any interesting projects that are being worked on where people and robots cooperate?
Yes.
Can you describe them a bit for us?
A new buzzword in robotics is collaborating robots. And collaborating robots are not the term of two robots collaborating. It actually means that humans and robots are collaborating. And that's really the buzzword now. And I came late to this interview, sorry, because I was out actually fixing some minor bugs on one of these collaborating robots.
That's the only excuse we acknowledge here on the show. I was out there doing robotics. Then you're immediately and automatically forgiven. Because that's cool. And that's also the thing that everybody says, being out there working with robotics in the field, trying to solve a problem somebody has. That's the fun part. That's the rewarding part.
Exactly.
What kind of system was not doing what it was supposed to? Can you describe that for us?
It was actually a sensor, and sensors and outcoming light is always a problem. So we have to shield the light somehow.
Yeah, I know many sensors struggles in the outdoor environment, and
that's because there's still a difference between human sensors and robotic sensors, because we have logarithmic sensors in here, so we do not feel very bright light as bright as it actually is, but other technical sensors do. So they are blinded by the light, which we're not blinded of.
They need an iris, the robots, to adapt themselves.
Yeah, but also internally in the individual sensors. They are quite clever as well.
Oh yeah, I mean the human eye and other eyes that are available in nature are just amazing, and also our image processing is very impressive.
Yeah, it is actually.
Yeah, many magnitudes more impressive than whatever computers can do right now. Am I right?
Yeah, definitely. Our brain is fantastic in doing parallel processing. So if a fly comes out here, I'm pretty sure I could say within tenths of a second that this is a fly, although I do not look directly at it.
You just learn the profile of the sound, and we could tell the difference between a fly and a wasp and a bumblebee.
Everything. Also because we combine all the inputs from our senses. So I can hear a bumblebee, which has a different sound than a fly, etc.
And we also use context to sort out the fact that it's probably not the helicopter because we're inside, right?
And it's probably not a lion, but a cat coming here because we have no lions.
Yeah, when you hear hoofs, think horse, not zebra, right?
Yeah, exactly.
If you're not in the Serengeti, then think zebra, not horse. So the human basic algorithms in vision processing, but also the higher logic is very advanced. So you're out there doing projects like the one that wasn't behaving properly. Can you talk a little bit about what projects you're working on right now and opportunities and challenges you have in those?
We're working on a lot of different projects actually, but we are primarily looking at collaborating robots. We're looking at modular robots. We're looking at flexible robots, and now I will tell you what I mean with that. Flexible robots is robots that you can use for more than just one task, because many small medium enterprises have small batches, and if you have a small batch which you have to produce in the next 3 days, it can't help you with a robot that it takes 2 weeks to program. So it should in itself be very flexible, so you can adjust the program and you can replace the grippers, for example, so you can grip different parts.
Add degrees of freedom, add sensors.
And you should be able to do that quickly. So that's the modular part. Adding new modules, new fixtures to hold your parts, new hands to grip and move your parts, and new software programs. So operators at the lowest level in the factory actually can quickly change the behavior of the robot.
Fascinating stuff. Really cool. You also talked about there was modular robotics, software, flexible robotics, and
collaborating. Collaborating means that you can actually share your workplace with a human, or
interact closely with the robot.
Workplace with a robot. Yeah. So you can work on the same workpiece. Doing different stuff. And in order to do so, the robot should of course be very safe.
We don't want any accidents, huh?
No. So they should actually be able to figure out if a human is close. So they could either do that by when they have contact, they can feel the contact, do it very smoothly, and then return and say, okay, here's a human, I'll wait until the human is gone. Or they could do it with vision sensors, etc. So they could, if we're talking about very heavy robots, strong robots, they could stop moving if people come closer, and then they could start working again when people go away.
No, this is fascinating stuff, because this allows us to exploit the benefits, the strength of the human and the strength of the robot together, and that can really supercharge what we're trying to do.
Yeah.
What kind of applications are these co-robots designed for? Is it production, or is it field work, or?
Right now it's primarily production, because in a production environment you have almost always fixed light, and you have a fixed environment. You have tables which are flat, instead of, if you are talking field robots, you're on a field which changes all the time, and you have the climate is also a little problem, because you have to design the robots so they can stand rain, hail, snow, frost, hot sun, and that it makes it more difficult. But in a production environment, you have a fixed environment, so it's much easier to develop robots, and that's why most robots are developed for that kind of environment, and then then you adapt it later to other more advanced environments to make them work.
When we're talking factory work, is it more or less any factory work, or is it assembly or kitting, or what kind of work are you doing?
What I'm developing robots for is primarily assembly, because if we're talking about picking and placing parts, that's more or less solved as long as parts are in a fixed place.
And very well known, the general grasping problem is anywhere.
Yes, but that's also to be solved very soon using collaborating robots, because there's a technique called bin picking, which means pick a part from a box where all parts are in a mess.
Random pile.
Random, yeah. And that's very difficult and very expensive today, using robots and sensors for that. But we can solve it more easily by just adding all parts in a plate where they lay in only one layer, which makes it much easier for vision systems to identify individual parts, and for a robot to pick them, because they have to pick them in the same height. And in order to do so, operators could just take a bunch of parts and do like this, put them in one layer, and then let the robot do all the trivial stuff by doing like this every 30 seconds.
And then you also get that human both touch and vision processing and saying, are these components okay? And then the robot can go out and do the same motion 50 or 100 or 1,000 times. And one operator could also service many robots doing this, and keep an eye on things and keep an eye out for abnormalities, because humans are very, very good at spotting abnormalities. There's something going on there. I don't know exactly what it is, but I'm going to focus my energy on that.
Yeah. We also start using robots for that. because we can hear a sound. A machine go do 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 do. Something's wrong. And now we are opening the field of big data, because if you had a computer system or robot actually listening to the sound, it could tell you something is wrong here.
This machine usually doesn't sound like this when it's doing what it's supposed to.
And the robot systems could actually be better, because they could also hear the little difference, which means that a bearing is about to break, which might not be bum 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 bum, but bum 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 bum. Over days, and humans adapt.
We do it more or less.
We actually adapt to a change, so we don't really hear it. But robots or computer systems could actually hear stuff like that and tell you, please fix this machine before it crashes.
And it could also use sensors that we don't have for low frequency or high frequency. It could also use thermal imaging, for instance, and see this machine is getting hot. That's probably not a good thing.
And we're actually using that special technique to see cracks in special parts, because you can see that if you heat them up, you can see it in the infrared spectrum, that there's cracks
the crack becomes visible. The cracks become visual in the infrared.
Yeah, exactly.
Very interesting, very interesting.
Yeah, and we have some other fields we're looking into, such as waste sorting.
Very challenging problem.
Yeah, because a lot of humans actually stand there, sort out all our waste. And we can do that with these advanced sensors as well, because if you heat up different materials, they cool down in different ways. So you can use a flash to heat them up shortly, and then you can look at it with the infrared camera and see, oh, this cools down fast, so this must be paper. This is not that fast, must be 3 or wood. This must be metal, because this is still hot.
Yeah, that's
this
really
way you
cool.
can actually take a waste stream and then split it up in two, and then do that vice versa down, finer and finer sorting.
Yeah, that's cool. Could you also tell apart, for instance, glass and metal and different kinds of metal?
Yeah, you can actually do that.
That's cool.
Some are magnetic and some rely on inductive sensors and stuff like that.
Really cool. So that's a kind of what you can call an active sensor, when the sensor first transmits energy into the world and then looks at not the actual result, but the change in the result.
And that's actually one of our projects these days, because we're trying to sort electronic waste out of standard waste. Because in electronic waste, the density of gold, for example, is 10 times higher than in these mountains where we usually find the gold that we use.
So the gold mine is now in our old TVs and computers rather than in the mountain.
Let's go for that.
Yeah. So yeah, that's very interesting. Could you mention some other projects that you've been working on over the years?
Oh, we have been working on so many.
Yeah, take the one that really surprised you with the result. Maybe like the solar cell, that is totally clean one. Something that surprised you, something that you found that you really learned from.
We have another project where we're trying to use vision sensors to pick parts. And then we added a force torque sensor on the hand, and what we could see there is the vision sensor could tell us where to pick, but didn't tell us whether parts actually were overlapping, because they had a complicated structure, so we could only see the top, which gave us an idea where to pick, just as a human when we pick stuff. But when we pick stuff, we actually feel that this is too heavy to be just one part, so there must be more parts, and I have to do like this in order to split them. And when we got this sensor on the robot, we tried to look at the data and then said, if we use this kind of data, what could we do? And we figured out that maybe bin picking would be much better with the blinded eyes and just a sensitive robot hand that could actually feel stuff instead of a seeing robot with a boxing glove, because it can't feel anything.
No, you and I can do that. If we can pick something up in the dark and know if our cell phone is attached to the charger because we feel the pull of the cable, and then we know either we have to be careful or we have to pull out the cable.
Yeah, exactly.
We can by the feeling of the item.
Grasp two different parts and put them together. And what we do without thinking is actually we turn them in the right direction so they fit when they come to it.
Yeah, for instance, again, attaching your phone to the cell, to the charger in the dark when you go to bed.
Yeah.
It's
not a problem for us.
No, we take this for granted, but robots have a hard time doing that still.
Yeah, and other interesting projects is to make better grippers, flexible grippers, like our hand. But if you look at a traditional robot arm, it has only 6 joints that it has to control. And here, I guess we have, I guess it's something about 15, 20 joints. So a hand is much more complicated than an arm. But eventually, I guess we will have flexible grippers like this that can feel stuff and manipulate stuff while holding it.
In-hand manipulation, you and I can do it with a coin or with a rubber ball or something.
Yeah.
But robots still are very challenged by that.
Yeah.
And you usually have to do that when you pick something up and you're supposed to use it in a process. Usually you can't, or sometimes you can't use it in the orientation you pick it up. You have to manipulate it in your hand to get it into the right position to do what you want to.
Yeah.
And that's still very challenging, I understand, from a robotics point of view.
Correct.
Both from the fact that the most advanced robotics hands are still not that good, and also the sensoring and the processing of those sensors is still not where we need it to be able to do that.
No. And what could be really interesting is if we develop a system where we can use the knowledge from operators, blue-collar workers, to actually instruct these robots. Because it might be my robot hand can feel a lot of data, but I'm not aware of which data, you are not aware, but we can look at stuff, and if I grasp something and I want it, if it's fit to something else and I know I just have to move it like this, you can just tell the system, move it like this, and it will split up into, okay, so the robot do so, and then it records all the senses, all the forces, etc., and then it can store these forces, and next time it's in here, it knows that if I'm if forces are like this, I have to do like this to split up. This way we can get operator knowledge into the robot systems in an easy way, because if I as an engineer should program all this, I would be a bottleneck. But if this robot systems go out to 1,000 factory floors where you have 10 operators, each place, suddenly you have 10,000 actually to develop these robot skills.
And the robots can, of course, share the skills between them much easier than humans can, because when one robot in one situation has learned something, it will, of course, share that with other robots, and they suddenly know how to do it.
Yeah, usually it will, of course. Maybe in the future we will have robots that deal with each other. If a robot sees something, it says, has anyone else seen something like this before? What is it? What can I use it for? How do I split it? How do I assemble it? Etc. So I guess in 30, 50 years, robots will actually communicate a lot about these things, and maybe we will be the one to benefit because we're the one arranging the business of the robots.
Very interesting, very interesting. And some of these problems are very challenging, but you're making good headway, and that's very impressive. You have a wide and deep knowledge about robotics in both in niches and in general. Where do you see progress being made? Where are we going to see robots being used, maybe in our homes or in our businesses? We have the robotics lawnmower and we have the vacuum cleaner. I've heard about window cleaners. Where do you see the next one that's going to take that next step on the road to a robotic world?
I would say that now we are in an era where robots become safer, so they will become closer to us. We will work together, and in the welfare sector, robots may actually help us. It might give us arms that we do not have.
Very significant. Huh?
Yeah, you can have a third arm. Someone may have their first arm, which is much more beneficial for them.
Yeah, I mean, I've seen those more advanced prosthetics coming out,
exactly.
And it's just amazing what we can do and how we can help the people that really need it.
Yeah,
and towards independence.
Exactly, in many fields. Very exciting.
So, can you tell me a little bit about how the Danish Technological Institute work? You're not a research university. You're not a school, or can you give them an overview of the center and how it works, and how people out there that see this interview could cooperate with you? And
yeah, we're actually a non-profit independent organization. We are in research projects and we are in commercial projects, because we would like to take state-of-the-art technology. We would actually like to push the state-of-the-art technology. That's why we are in research projects with other national and international research institutes. What we research in is chosen from what we see in the industry, because the industry have some demands saying we need flexible robots, for example, collaborating robots, etc. And then we can take these demands, formulate them into some research projects, get some funds from the EU, for example, develop some technologies, mature the technologies, and take them back to the industry.
How do you see, how do you see the trend when working with industry and working with people or organizations with domain knowledge? Is it easier now to come and say, look, we've looked at your what you do in your business. I think there's an opportunity for robotics here. Should we cooperate? Is there a difference in the end user approach now or before, maybe like 5 years ago?
I don't think so.
It's still hard to convince them.
It's still hard, and that's why it's very important to get a good contact to these companies and bring them into the research projects
early.
From the very start actually. So we're working on their cases, so they can see that the technology actually can solve their problems. That's a good way to make the companies get interested in new technologies.
Get them in early, show them that there are solutions for their problem.
And some actually focus on their problems.
Because the company more or less has to focus on their immediate problems, otherwise they'd be in trouble. But if they see that this is, as we talked about before, especially for smaller companies, this is reasonably easy to implement, this is reasonably quick to implement. It doesn't, if you're thinking I want to use robotics in my company, it doesn't necessarily have to be a multi-year, multi-million-dollar project. You can start with, you could possibly start with something small now, immediately here, and that solves a small or significant problem for you, and then you can work on from there. Huh?
And today, in Horizon 2020, companies are actually being paid to join, because the EC have also seen the challenge of actually getting committed companies in their research projects.
Very interesting. Yeah, I've always known that the end user is a very challenging connection to make, but it's also a very important connection.
Crucial to get the real results.
Yeah. Otherwise, it's like driving a car in the dark. You don't know where you're going, and you don't know if you're on the right way.
No, and we shouldn't trust what we believe is the best for the industry. We should ask the industry, of course.
And it has to be a collaboration, because sometimes the industry doesn't understand what is hard and what is not so hard and what is achievable and not. So this has to be a true cooperation. And you can take a project all the way from fundamental research all the way to a commercially applicable solution.
Correct.
Can you talk about any such projects that you've done that you got in touch with the end user, you did some basic research, you made a product out of that, and then you delivered it to whoever is using it now?
I have a simple, successful example. If we're talking screwdriving processes, I've been at many factories seeing electrical screwdrivers like this, hanging all over. Some companies operators use 50% of their time just doing like this, and the rest of the time they pick parts and place parts and do some assembly stuff. But this is the same. So why not just take this screwdriver, electrical screwdriver, a robot, a vision system, put them together, and you have the third helping hand that could do the screwdriving. So you could do some assembly, put it here, let the robot screwdriver take it back, do something else, etc. So it will take all the trivial tasks, do that in an efficient way, and you can do what is more difficult for robots and perhaps more exciting for people.
Very interesting, very interesting.
And that's we did that in some of our research projects. We went to the industry, saw the problem, saw the demand, heard the demand, took it into a research project, and then developed some technologies, simple technologies, but now it's actually gone back to the industry and they are started using these robots. So that's a fantastic story.
I also understand that the first robotic solution you sell into somebody that hasn't previously used robotics can be a challenge. You have to overcome many barriers, and they really have to understand that there is a clear and present use of these and a benefit from using them. I also understand that the second robot you're trying to bring into somebody is much easier. Have you noticed that? Have you had any projects with reoccurring partners?
For sure. The first robot, what we actually tell companies today is that the first robot investment is an investment in getting knowledge about robots. It doesn't necessarily solve that many problems in the production, but you get to know what is possible, what is not possible. You will be able to figure out who of the operators are actually very interested in robots, who will come with the next idea, and who will take that idea and make it into an interesting installation. But you need a robot in the factory, in the production, to actually start that process.
You need to show people that this is real and it's now. It's quite a bit about what the show is about, to show, to allow you guys to tell your story so that the viewer knows that it's real people, this is really happening, it's not science fiction and it's not scary. And I guess that first icebreaker robot does this in a company or an organization. It shows people that there's a very clear benefit. Very interesting.
Because 5 years ago, many companies had the feeling, or many human workers had the feeling, that the robots actually took their job. I'm going to be fired if we bring in robots here. So they all were a bit defensive. But nowadays, it actually is the opposite. I'm talking to many partners, stakeholders, also unions. And in some workplaces, in some factories, it's actually the blue-collar people who are asking for more robots.
Because it makes their lives easier and their work day more productive.
And they also know the alternative. Because the management say, more robots, outsourcing, more robots, outsourcing. And if they choose to outsource, there will be no jobs left.
No.
So the blue-collar workers say, okay, might be we have to go down by 10% or something like that in number of workers if we get robots, but we still have 90% of the workplaces. And if it's becoming a success, we will have to produce more, because we can produce to a lower price, our productivity raises, we will sell more, and then we will have to take in more workers. And I've seen that actually happen more places.
Yeah, and that's what I work with, and with this show, and trying to show people that robotics doesn't necessarily have to be scary. And we've also gone through these kinds of evolutionary processes many times before, the introduction of steam power, water power, or electrical power, and many different systems. I mean, I heard the fact that in the early 50s there were 40,000 people going to work in New York every day as elevator operators. And now we have buttons instead. It doesn't mean that everybody in New York is out of those 50,000 people are still out of a job or that their lives are worse. It just meant that new technology come in, could do something useful, it was exploited, and nobody claims to be worse off now anyway.
No. I've also seen statistics saying that 50% of our jobs are gone in 20 years. And I say, thank you for that, because they will become a lot more interesting jobs for us. If we go 20 years back, and I say, please check your email on your smartphone, they would just say, what a crazy guy.
Check your what on your what? Because they don't know what email.
Internet was even started at that time. And now, how many people are actually working in that sector? On the internet sector, smartphone sector, etc.
Millions and millions
these
of people.
kind of technologies.
Yeah, this has been very fascinating. We've learned so much about what you do here at the center and heard about research project and also commercial projects. So I'd like to thank you very much for taking the time to do an interview. And we're going to follow the work of the center and you as it goes along.
Thank you for having me.
This episode is sponsored by Aptomica. Everything you need in modular robotics. Or robots up close. What's going on in robotics, online and on the road. If you like this interview, don't forget to subscribe, follow us on Twitter, and subscribe to our email newsletter on robotsindepth.com. You can also support the show on Patreon.